Welcome to Through Inquisitive Kids. This is the third lesson of Chapter 7, the Quotient of Powers. This is our course outline for Chapter 7. This lesson will be the last lesson of the laws of exponent, and the next lesson will be about using the scientific notation to rewrite smaller numbers. Our learning goals for today is explore the Quotient of Powers property, understand zero and negative exponents, and being able to use the Quotient of Powers property while simplifying expression. Do you still remember the product of powers property? The number on the bottom, or the expression on the bottom, is the base. It doesn't always have to be a number. And the number on the top right corner of the base is the exponent. The product of powers property tells you to add up the exponents, but the base stays the same. And m and n, in this case, are both positive integers. Use the product of powers property to help you solve the following problems. For 2 to the 8th power times 2 to the 7th power, you should get 2 to the 15th power because you add up the 8 and the 7. You add up the exponents. Same for the rest of these problems. You'll get 5 to the 5th power, a to the 7th power, and 3 to the nth. Now I want you to fill in the blanks. So in the first parentheses, it's going to be 2 to the 8th power, because 2 to the 8th power times 2 to the 7th power equals 2 to the 15th power. You add up the 8 and the 7. For the second problem, you get 5 to the 2nd power, 5 squared. And for this one, you'll get a squared. And we know that multiplication and division are inverse operations. So what is 2 to the 15th power divided by 2 to the 7th power? Knowing that multiplication and division are inverse operations. So maybe you're reversing the product of powers property. If you manage to get these correct, you would get 2 to the 8th power. For the second problem, you'll get 5 to the 2nd power, a squared, and 3 to the nth power. Did you find any patterns in the calculations above? Well, I noticed that 15 minus 7 over here in the exponent section equals 8. 5 minus 3 equals 2. 7 minus 5 equals 2. And m minus the difference of m and n is n. So this has something to do with the product of powers property, but instead you're not adding, you're subtracting. But instead of adding up the exponents, you're subtracting one exponent from the other. So this equation right over here is the quotient of powers property, and this is what we're going to be learning today. A to the nth power divided by a to the nth power equals a to the n minus nth power. So we can rewrite the division sign as this big line over here as what you would see in a fraction. On the top over here, there is an m number of a's getting multiplied together. And on the bottom, there is an n number of a's multiplied together. And then you cancel as many pairs of a's as you can find from the top and bottom. So you get an m minus n number of a's multiplied together. And then you get a to the m minus nth power. So basically, this equation is true, and a does not equal 0, and m and n are both positive integers, and m is greater than n in this equation. The base stays the same, and you subtract the exponent of the divisor, the exponent of the second expression, from the exponent of the dividend, from the exponent of the first expression. So it's n subtracted from m, which is m minus n. Now we're going to be talking about 0 and negative exponents. I want you to take your time and fill in the blanks. You should be able to find a pattern over here. So for the first one, you get 10 to the third power, and then you get 10 squared, and then 10 to the first power, which is basically 10 itself. Over here, you have 10 to the third power, and there are 3 zeros over here in 1,000. And in 10 squared, there are 2 zeros in 100. And in 10 to the first power, there's only 1 zero in 10. Now I want you to try both of these rectangles. Well, in the first one, you should get 3, 2, and 1. 2 times 2 times 2 equals 8. 2 times 2 equals 4, and 2 times 2 to the first power is 2. Now we're going to try this pink one. 1 equals 10 to the what power? Well, 10 to the 0th power equals 1, because if there are no 10s multiplied together, there's always that remaining 1 that you can always find in multiplication. And over here, it's 10 to the negative 1th power, which will give you 0.1. And then over here, you get 10 to the negative 2 power, which is 0.01. And then you have 10 to the negative 3 power. So there will be another video in the description below to explain the laws of exponents more clearly and to prove them. If you don't really understand, we totally get it. But we hope you just finish the rest of this video in order to get a quick preview about the 0 and negative exponents. So for this last rectangle, you should have 0, negative 1, negative 2, and negative 3. The 0th power of any number besides 0 itself is equal to 1. You might think it equals 0, but there's always a 1 left over that you'll find in multiplication. And we use a to the negative nth power to represent the reciprocal of a to the nth power. If you don't know exactly what reciprocal means, you should be able to find it in a fractions video. So a to the 0th power equals 1, and a does not equal 0 itself. And a to the negative nth power equals a to the nth power equals 1 over a to the nth power, because it's the reciprocal. Summary. When applying the quotient of powers property, you subtract the exponent of the divisor from the exponent of the dividend, and the base remains the same. A to the nth power over a to the nth power equals a to the m minus nth power. A does not equal 0, and m and n are both integers. They don't have to be positive. Any number raised to the 0th power equals 1 besides 0 itself. So a to the 0th power equals 1, and a itself, the base number, cannot equal 0. So a to the negative nth power equals 1 over a to the nth power. And you can also rewrite it like this. A does not equal 0, and n is a positive integer. And that's it for 7.3, Chapter 7, the Quotient of Powers property. If you really did, and we hope to see you again in the next lesson. Thank you for watching, and please remember to click that subscribe button and click a thumbs up.